Hello, everybody, and welcome to the next stage of our Revit Structure webinar series. Today, we will be presenting concept optioneering with Revit Structure. This is certainly an underutilized function and benefit of using Revit, so we're excited to be able to showcase what we can do for you here today. Today's presentation does form part of a wider webinar series that we are running, focusing on Revit Structure, and it's great to see so many people in attendance here today, including plenty of familiar names who have been with us along the journey so far, as well as some new ones. So I hope you can all take a bit of value out of today's session. The agenda here for today. So look, we'll be talking about the value of concept optioneering. So obviously, as I mentioned in the results, we just ran through our poll. Sometimes some people do see value in it, other times people don't. So we'll run through concept optioneering and just what the value that can actually provide to you as the designer or drafter, as well as your potential client, stakeholders, and the general public as well. We'll then move through into different options for actually developing your concepts. So we've got the 2D versus 3D comparison there. Again, the poll showed that most people are still doing things in 2D, so that's quite exciting because we'll then move into a live demonstration and we'll be showing you some really good ideas in terms of developing these concept options in 3D and how it can really benefit your overall projects. My name is Ben Hipsley. I'm hosting the session for us here today. I do certainly have a structural background, spent over a decade mostly designing bridges for a number of firms and for a number of large projects. I'm ably supported as well by one of our structural application engineers, Asif. He will be running through the live demonstration portion of today's presentation. So to kick things off, obviously, we've spoken about the value of concept optioneering. Now, from my experience, the value of the concept phase of a structural project, it can be overlooked. Again, justified through that poll we ran a little bit earlier. It certainly can be overlooked, when we look at it with respect to its importance in the overall project. So in many instances, we provide the most simple and the most basic option that we can in order to get straight onto the detailed design portion of our project, and we save our hours and our budget for that phase. So I wanted to start this presentation today just by discussing the importance of concept optioneering phase and the impact that this phase can then have downstream on your project, and how it certainly will save you time downstream on your project. So at the concept phase of a structural project, it's critical that we do present multiple design options to our client, not just as a courtesy, but to ensure the success of the project for ourselves, for that client, and then also for the general public and any other stakeholders. So firstly, for each structural concept, it inherently will involve some trade-offs. So that can be between material efficiency, it might be constructability, it could be program duration, and of course it could be cost. So by presenting different options, we allow the client to align the structural solution we're presenting with their broader project priorities. So whether that's minimizing CapEx, it could be sustainability, or it could be prioritizing that construction timeline. So from an engineering standpoint, early decisions can have a major impact downstream on a project. So for example, a structural grid choice, it might not just affect the superstructure, but also the foundation. It could impact the facade. It could even impact that MEP or architectural coordination as well. So multiple options ensure that we're testing these decisions against key constraints. We're not just defaulting to a single assumed solution. It's also a proactive way to manage uncertainty. So at the concept stage, input from other stakeholders, whether that's an architect, could be a geotechnical engineer, could even be a planning authority, that all might be still be evolving. So providing options, it'll allow us to develop our structural system and make sure that it's adaptable and it's flexible, and allows us to respond quickly when those inputs might change or confirm down the track. So lastly, when we involve the client and other stakeholders in reviewing those options early, we're going to avoid surprises later down the track. So it reduces the redesign cycles, it'll foster collaboration, and then it ultimately leads to better engineered and better coordinated outcomes for everybody. So now that we've looked at why generating multiple concepts is valuable, we can then focus on how we develop and present those options and why Revit offers a clear advantage over traditional 2D workflows or hand sketches. So you can see in my table here, we've obviously got a column here. We're comparing different parts of our concept options against Revit or 3D modeling in general versus more traditional sort of sketches and 2D drawings. So at the concept phase, the goal isn't just visual communication, but it's also about setting up a model that can inform design decisions. It can integrate with analysis tools, and ultimately it can feed your downstream deliverables. So Revit will let us do all of that in a single environment. So to start with, modeling in 3D, it gives us a far more accurate and spatial representation of the structure. So we can immediately assess how elements relate to one another, but even more importantly, how they interact with site constraints, or it could be architectural or MEP inputs as well. With sketches or 2D CAD, you don't get that level of coordination until much later down the project, which can often lead to rework. You're going to see a really good example of this in a couple of minutes from Asif. So secondly, Revit enables quantifiable design from the outset of your project. So by creating a data-rich Revit model, we can very easily and accurately schedule materials, we can approximate quantities, we can even extract data for early costings, all of which is basically impossible to do efficiently with manual drawings. So in terms of iterations, Revit is far more agile as well. So we can create and manage multiple design options using the built-in design options toolset, with each iteration remaining connected to that centralized base model. So changes are tracked and version control is easy to manage. And again, we're going to see a really good real-world example of that in a couple of minutes. So another major technical advantage is interoperability with structural analysis tools. So concept models can very quickly be linked directly into analysis tools such as Revit Structure, and that will save hours of redundant modeling during that concept phase, but also further into the detailed design phase as well. Another thing is we'll also gain the benefit of early clash detection and coordination checks, even at the concept stage. So if we're federating models in Navisworks or the construction cloud, that's something that's simply not able to be done with static 2D files. So one other application is if we take a step back from concept options and look at the tendering and bidding phase of a project. So say it's a rural local council, they're tendering for the design of a replacement timber bridge. I've done dozens of these in my time. Much of the time, there's no architectural input for a project such as that. But using Revit, we can very quickly create multiple 3D options that can then be used as part of your tender documentation, which can go a long way to impressing your client and winning you that work. So that model could then also be used for data-driven decision-making, which can determine your project costing as well. So if you do then win the job, which is likely given the quality of your bidding documentation, thanks to Revit, that model is then very easily adapted into your detailed design phase, analysis, and drawing production. So as part of this presentation shortly, Asif will show you how easy it is to create a realistic visual from a Revit model, such as this. So this leads on to the last major benefit of using Revit early in your project that I wanted to highlight. So the models that you're building at this stage of the product are then easily adapted into your detailed design. So there is very minimal to no rework between the phases of your project. Traditional methods of concept optioneering through hand sketches or 2D CAD certainly creates a lot of work that then becomes redundant as soon as you move to that next phase of your project, and you're essentially taking backward steps. So ultimately, modeling concept options in Revit, it's not just about visual communication, but it's about building a data-rich model that will aid and accelerate decision-making. It will win you more work, and it supports better technical outcomes from day one. So that's enough of explaining why it's important and then what Revit can do in the early stages of that project. It's time to actually see this in practice. So I'll hand over to my colleague in Asif. He will show us a live demonstration of the design option tools in practice. So Asif, I'll let you take over. I'll just stop sharing my screen.
Thanks, Ben. Can you hear me?
Yes, got you there.
Let me share the screen one more time. Okay, is it sharing properly?
Yes, yep, we can see your desktop.
You can see me. All right. Okay. Thanks, Ben. Good afternoon, everyone, and welcome to the webinar Concept Optioneering with Revit Structure. My name is Asif Hossain Khan, and I'm the technical presenter today. I work as a structural application engineer and structural drafter in CSS. In case of optioneering, Revit has a wonderful tool which is called design options. But I think it's the most underutilized tool in structural engineering or drafting, and it has an obvious reason. Let me explain why it is. When a project is initiated at the primary stage, architects are the one who submit their initial design or concept with different options. Thus, this design option feature is mostly utilized by them. When a client finalizes one design option among many, then it is submitted to the engineer for structural design. Now, as you can imagine, at this stage, we don't have many choice to show up our design mastery because we have to prepare one single solution of the structure to sustain loading condition as well as keep sustainability in the long run. So without further optioning, detailed design is prepared with calculation and submitted to the client. However, despite of this phenomena, we still have some cases where design options in structural project can be utilized to make better design choice, and obviously from the economic point of view. Now, let me show you some situation where it can be utilized. Right, Ben, is it coming properly? Because I cannot see my
Yeah.
border over there.
Yes.
All
We
right.
can
Okay.
see your screen. Yep. If you can just
All right.
pull open
Perfect.
the model. Yep.
Okay. I'll go through this file first. All right. So I'll start with this file, and if you're wondering how did we make it, we already run our first webinar. We did entire model within just 30 to 40 minutes, prepare total documentation, scheduling, and everything. We also showed how the changes made, and the webinar was migration from AutoCAD to Revit. And if you're interested, I highly recommend you watch that webinar. All right, I borrowed that model from that webinar. And let's say, let me show you where you can find the design option when you open the Revit. So if you go to the Manage tab and then come over Design Options panel, there it is, the first icon. Once you click it, this is the window. It will be shown Design Options. Now, I already have prepared a few of the design options over here, and I'll explain it to you right now. Okay, if you have attended the first webinar, and if you can remember, we created a hole over here to put some sort of line drawing and texting to communicate with the engineer that this is the location where we want to put a tank, such as we already have put a tank. We got the tank from the engineer and we put it at this location. Now it's time to prepare some sort of supporting system for this tank. Now, design option can also be found at the bottom of this window where it is said main model. And if I click on it, and I have 4 models set up. So if I press the first one, as you can see, anything on this design option that's going to be presented and rest model will be grayed out. And basically the rest of the model, which is grayed out, we usually call this main model or the base model. And once you in any design option, then you will not be able to select anything at all except those elements you put in the design option. Now, this is just for the placeholder because I just prepared one blank one to describe it properly for the sake of this webinar. Now, as you can see, this is these are the 2 tanks, and we need to prepare some sort of support system for this tank. Now, for example, one of the engineers came out and then said that, okay, I have a solution, something like this. So I'm just switching my options from 1 to 2. And there it is, as you can see, beautifully arranged, and a design option can be seen properly, that how it is interacting with the rest of the model and how is it supported. Now, okay, before I proceed, I need to tell you one thing, that these design options can be assigned to different level plan. If I just go through quickly, as you can see, this is my design option 1. Let me switch it to main model. And design option 3, design option 4, and also it can be assigned to the 3D view as well. Let me close all the inactive views. All right, great. I'll show you from here so that you can understand what is going on. So this is my design option 1, where I have separated everything, separated this part from rest of the model. All right, great. Now, another engineer probably has come out and said that I understand the context, but we can minimize the material consumption by modifying some sort of arrangement. And he maybe came up with something like this. This is design option 2. Design option 3. All right, great. So you might be presenting to the board meeting or other stuff to communicate properly that how it's going to impact on the project. Now, possibly after the second one, another engineer came out and said that, yeah, I can understand what you're trying to say, but it's this arrangement is putting load concentration on particular point of the beam. So we can better distribute in different way. And probably he came up with another solution, which is option number 4, something. If I double click, it's going to open up for me, something like this. Yes, once these 3 options are done, then it's time to present in front of the board meeting or to the client or management that how we are trying to resolve this issue. And once this is done, I'm going to put it, I already have set up my sheet view and I put all these views over here. Now, once people seeing this, probably one of the stakeholders have come out and said, okay, among these 3 design options, which one is the cost-effective one? Can you please tell me? Yes, surely. So in case of cost-effective point of view, we are going to show them that how these framings are done, what is the length, what is the cost, so that stakeholders can make a better design choice, decision making in this case. All right. To do that, I already have my structural framing schedule set up over here. If you're unsure that how did I do this, you must watch the first webinar. I already have showed there how to prepare this schedule table, because when you try to do it in AutoCAD, you draw the table, fill up the information, and when the change occurs, then again you have to do it manually. Whereas in Revit, it's just pretty much easy, automatic. Okay, great. In last webinar, I put 4 columns over here. Now, in this case, I already put 2 additional columns, which is called cost per meter and total cost. If I diagnose over here, as you can see, I input cost and total cost, 2 more input over here. That's why it's coming like this. Now, I didn't put any kind of real world value. I just input some value so that you can understand how this is cost is calculating. So this total cost basically multiplying cost per meter plus into multiplied by counts as well as multiplied by the cost cut length. And that's how you get the total in one row, and then you get grand total at the bottom. All right, now it's time to place in this design sheet so that we can present our design with some costing. Once I drag it, drop it over here. Now, you must be asking by yourself which table this is referring to. Is it referring to 1, 2, 3, 4, or is it counting everything into the table? And that's a very good question. And in this regard, we have a wonderful system in Revit that you can assign different design options into the table. Now, let me go to the table first. Let me show you where it can be found. Once you're in the table view, then come to the graphics section, visibility and graphics override, click here, and there it is. It's showing you, if I pick this drop-down list, it'll be showing you which design option do you want to see on this table. Now, for example, as I said, that first one is the blank one, which I created intentionally, but in your case, it's not going to be. I'm going to switch it to option 2. Now, keep your eye on this design table, how the things change. If I select option 2 and apply, immediately there are 4 rows came out instead of 2, which is basically reading the information. Oh, excuse me, I forgot to press. Yeah, anyhow, let me switch it back again. This is option 2, apply, and okay. Now, this is reading all the information of the framing only from the option 2. Now, it's time to change the name, structural framing. option 2, I'm being a bit descriptive so that I know which table assigns to what. Otherwise, I may get lost. All right, great. So that's how we created our design option 2, 3D as well as in the table. And now I'm going to put it on my sheet view. And there it is. As you can see, the costing is calculating. You can input real world value, then it will come up as it is. Okay, great. Once it is done, now I'm going to go for the third one. I'll copy this one, duplicate, right click, duplicate, and this is reading. Say this one I want for the option 3, and I'll definitely change option 2 to 3. Supply, as you can see, number of rows minimized, and this is reading exactly the same information from option 3. I'll drag it over the drawing sheet and place it in option 3. Now, one thing to mention that I already filter out some of the members. As a result, you will only be able to see the framing of this part, this green or the colored part, which is assigned to different design option. And obviously on the other side as well. So I'm going to create another one, as you can understand, just creating duplication and then assigning design option before apply, and renaming so that I know which one is assigned to which design option. And there it is. Drag and drop. And that's how we represent the board of directors in front of the board of the directors, or in the client meeting, or in front of the internal stakeholders. And they can now see what the design options are in 3D. I have already mentioned you can also assign the design option into 2D. You can create separate sheet for that, and you can assign this 2D layout as well. So from this scheduling, from the 3D, engineers plus internal stakeholders or external stakeholder can make a better design choice, and which design option can be economic. All right, great. I guess you understood one of the valuable part of this design options. Now, one thing I would like to mention that you might be thinking that, okay, we have a file, so why don't we just copy this file 4 or 6 times? For example, you have six options and you copy this file 6 times. Now, one of the danger of doing that is if the base model changes, when I say base model, it's basically the rest of the model I'm talking about. When the base model changes, such as the member size change, member orientation change, plus grid line shifted left, right, up and down on the plan view. And in that case, you have to do all the changes to all the 6 design options. And if you anyhow forget to change one of the particular thing in one design option, then it may be impacting the length and the quantity, sorry, not the quantity, basically the length of the member. And that will come out as a wrong information. And luckily or unluckily, that design option was chosen as a final design, and estimators probably overlooking everything. They will be going through the sheet and they will say that, okay, I got the information from here, just input and send it to the fabricator. Fabricator will be fabricating, send it to the site, and site people will be scratching their head why we cannot attach, because the member size will be oversized, undersized, and they'll be scratching their head. Then the coordination, then investigation will start up. How did that happen? A lot of coordination problem will occur. That's why it's very useful to use one single file instead of multiple files and create as much variation as you want in design options, so that if your base model changes, everything changes automatically. The schedule table will change automatically. You don't have to do any kind of manual work. Okay, great. I guess you understood one of the context of using design options feature in Revit Structure. I'm going to give you another example. Let me close this. Okay, and this is another example. All right, it's a kind of situation over here. I just cut out from my previous work, some duct line is going on. There are concrete walls, and there's a air conditioning or some sort of mechanical, electrical equipment that you need to rest. And this is the perfect choice the client has asked me to do. And probably we have laid out our base model over here that we can do some sort of cantilever action, something like this. And we can put our this equipment to support the load. Now, this is not sufficient enough, as you can see. So from this point of view, one solution we provided at the very beginning, which is like this, as an angle bracket and triangular formation, so that the load can be handled properly. Now, I'm going, instead of showing from there, I'm going to my 3D design option setup on the 3D so that you can better visualize. All right, like this one was the first solution was provided to the client, and client laid out his ductwork and then say that, okay, my ductwork is clashing with your design element. Can you please revise it? Yeah, sure, why not? So the second solution we provided something like this. Okay, it's a bit of fancy style, I believe, but because the positioning of the equipment from the wall and because of the ductwork, we probably have to choose some sort of design like this, and that's not clashing with anything, but that's just wonderfully working. And now client maybe found that, okay, it's consuming more material than the first one. Can you please revise this design one more time? And on this design, nothing is clashing, but still it's a client requirement, client's request. So the third option we provided something like this, the angle bracing connected from the top, and that's connecting to the main cantilever part of this structure. And that's the fantastic way of communicating with client. Probably client is happy and they gave us a green signal to go. Probably the costing is much cheaper than all the rest of the solution, but probably, sorry, I should have said that not cheaper, but this is the probable, from the costing point of view, from the arrangement point of view, this is the much perfect solution for the client. Okay, great. So I guess you could understood the use of these design options in different contexts. Now, let me show you the last one, which you can use in a bridge project. All right, as you can see, there's a bridge project over here. This is the initial layout, and okay, let me hide something, otherwise it's really hard to understand what is going on. Let's see with this. It is probably this is a bridge project, and this bridge is 35-meter long, as well as the width is set up depending on what kind of code provision do you have, like NCC, BCA, DA, disabled access, or if you're working for off-roads, then they have different width requirement. So possibly after reviewing everything, this one came out as a plausible design choice for the initial stage. And as you can see, all the framings are done. And at the end, there are two headstocks, which are connected by the pile. And this is the initial stage of the platform that needs to be supported. And as you can understand, if it's 35-meter long, 35-meter long framing, so it's really hard to just support on the endpoints and doing nothing in the middle part. All right, great. So we were asked to do some sort of support system. So the first one we presented something like this: two piers side by side, and then connected by the bottom beam, and some columns are attached. And this one was presented to the client, and client probably has reviewed with the other stakeholder. And this, let me show you one situation occurs here by going to unhide everything, and probably this one was rejected by the hydraulic engineer. As you know that if it's a water body and you're working on bridge, definitely hydraulic calculation involves. And because of these piers came in the middle of the waterway, So hydraulic engineer gave us some sort of feedback, and probably he's not happy with this. So everybody agrees that, okay, we need to change the design to the second, just give us another option. Great. So what did we do? We gave them a third option, something like this. Okay, great. And this case, let me show you by hiding. Hide it first, and then show you. In this case, we just shifted the piers from the center, from the middle, the waterway to the side, and put some truss bridge, and that truss bridge has some sort of SHS underneath, and that SHS is basically supporting the entire frame. And that was given to the client. Client was happy, and among internal stakeholder, probably architect was not happy, because architect is giving an objection that, okay, it looks like railway bridge. Can you please change it? Yeah, sure, why not? So we are going for the fourth solution, which is something like this. Probably architect is not happy at all with this design solution, and probably asked to revise one more time. All right, let's go for one more time. I'm just switching my design options over here. This one was presented, and even though architect was not happy, and if nobody is happy, then give them a Golden Gate Bridge on this pedestrian bridge. And yeah, surely Golden Gate Bridge doesn't have this arch. It could be Brooklyn Bridge. Okay, anyway, doesn't matter. But as you understood that you can effectively communicate and present your design options, I'm going to my 3D isometric, where this was presented every element, and probably everybody is happy. Now we can proceed from there, and that's how design options are created and presented to the client for better decision making. Now, one thing I'd like to mention over here, if you have installed Twinmotion for Revit, which is a free plugin, you can just push in entire model into Twinmotion, and then you can put some materials for the water, for the ground, for the steel members, for the wooden members, and everything can be customized. Plus, if you want, you can also populate some ecosystems, some human figures, which are animated already, given to the Twinmotion, and it can be represented how the project is coming out from the aesthetic and functional point of view. Also, in addition, you can also assign some sort of weather condition, plus daylight. How does the project impacts on the different daylight condition? And that's just wonderful tool. So that's not the part of today's discussion. We may be able to run it another day, but I guess I could be able to give you some valuable insight regarding the use of Revit design options feature to make a better design choice in your structural engineering project. And thanks again for joining this webinar. I'm done with my part. I'm going to pass it to Ben now.
Thank you very much, Asif. I think you might have missed your calling in life. I think you probably should have been an architect after seeing some of those concept options you built for that bridge. But anyway, I will crack on. So just as a summary of what Asif just ran through there. So look, we demonstrated some multiple use cases and some really good examples of how the design option functionality within Revit can it be used within your structural project. So we showed some structural framing at the start. And how you can very quickly and easily create material schedules, some cost programming, things like that, directly out of those concept options. We then showed how it can very much assist with coordination and clash detection with other disciplines and existing site constraints as well. And then that final presentation or example there was a really good way of just showing how these concept options can be shown as a visual representation in the real world as well. So look, as you can probably see from that, there is that really robust functionality to provide a lot of really good data and data-driven decisions can be made from the Revit models we're building at concept phase. And then as you can see at the bottom, that's then easily then advanced into the detailed design phase. So those models that we're creating, they aren't suddenly redundant. All of that work can then be taken forward into that next phase of our project. So, look, I've got a little bit of a list here. Obviously, this is part of a webinar series. So we do have a number of other webinars that we're running over the next week or so. What I'm going to do at the same time, I'm just going to pop up a quick feedback poll. If people don't mind just answering those couple of questions in there, it really just helps us improve on what we do through these webinars, and also gives us a bit of a direction into some other topics that you all might like to see. So while you're addressing that poll or that feedback, if you don't mind, so I'll quickly just run through what we've got upcoming in our Revit webinar series. So tomorrow we'll be showing some really great examples of the steel connection functionality within Revit Structure. And then next week we'll be moving on to concrete reinforcement, and then some of the more detailed integrations into some analysis programs and some shop drawing and fabrication programs as well. So look, there's some really great content to come. Use the QR code there. You can register for any and all of those webinars. You'll also find the YouTube links for the last week's webinars on that QR code as well. So you'll get all the information you need there. As I said, in the meantime, if you don't mind just providing us with that little bit of feedback through that poll, that would be fantastic. I'll leave that poll running just until we finish up here today, and I'll just close up with a big thank you. So thank you everybody for joining us here today and giving us your valuable time. And thank you also to Asif for his fantastic presentation. I hope everybody took some good value out of today's session. Thank you all again for joining us, and I hope to see you in our future sessions as well. Thank you very much.